Okay, so thanks, Tom. It's a pleasure to be here. So how many of you are incoming graduate students? Pretty good. How many of you are returning students who managed to sneak in somehow? A few timid folks. Usually that actually that happens, but it turns out that it's actually a good thing because they're scattered around. There are a few old hands who actually do know where the bathrooms are and that kind of stuff. So that's good. So I'm reminded of my first day as a graduate student. I did my PhD at the University of Minnesota, chemical engineering. And on the first day we showed up, they gave us a chemistry exam in order to correct deficiencies in our background. And I can tell you, based on comparing that experience to what you're about to see, this is going to be more fun. So welcome. It's great to have you here. Actually, we have a really good mix of folks. So those of you who are in Earth Sciences, that's my field, so we have to start with it. Earth Sciences, how many of you are? Oh, yeah, see, well, it was a pretty good group. How about engineering? Ooh, lots of engineers. Humanities and Sciences, so the science departments. Yeah, good representation. Education. Yeah, I don't see one. And School of Business. Whoa, lots. Okay, so of course, our goal in bringing you all together this week is partly to let you know something about what goes on in the energy arena here, but as much as anything, it's to help you get to know each other so that you'll have opportunities to interact in your years here at Stanford. And we know from experience that all of you bring perspectives that are needed in the energy conversation that we're trying to create, and good things will flow from having you know each other in ways that none of us will completely foresee right now. So let me just try to give you a little bit of the old why are we doing this? Well, energy, of course, is woven into every aspect of modern life. So some colleagues and I are teaching a new course for freshmen as part of our Thinking Matters sequence. And so for one slide there, I sat down and I tried to figure out everything I did in a single day that involved some sort of energy. And after I realized that this was going to take about 4 slides, I condensed it. But for everything from cooking my egg to making my toast to getting to the office to traveling, I mean, it's just everywhere in everything we do. And we take it pretty much completely for granted. Some parts of the world that's not true. And so we need to think about them. But at the same time, it's one of the ways that we interact with the modern, with every aspect of the global systems that provide us with all kinds of services. So it's intimately tied to the way we operate modern societies, and that means that we need to take it very seriously, both as a challenge to provide the energy the world needs, but at the same time to do it in a way that protects and even restores the natural systems that we count on for services like clean water and clean air and a climate that functions properly and so on. So there is plenty to do. And I think it's crystal clear that we need to be we are starting on a set of energy transitions in this century that will change completely the way we provide the energy to the world. And of course, what that's going to need is a bunch of really talented people to lead all of that, to do the underlying science, to do the engineering, to do the all of the policy and economics and regulatory and finance sides that all fit together to create the energy systems for the world. So that's our job. And I say it's our job, but the truth is that it's your job. So this effort is an attempt to bring you together to help think about that. So you can see that the challenge is really actually quite a big one. We have about 7 billion people on the planet now. Depending on which projection you look at, it's going to be 9 or maybe 9.5 billion people before we're done, or before we're done with the increase in population. And there are somewhere around 2 billion of those people now that don't really have access to energy services that we all take for granted. So that's an issue. It costs. The world spends, I don't know, $5 or $6 trillion a year on supplying energy, and it's about 7% of the U.S. economy. So that's a big number. I think it can be said fairly that there are international policy and military interventions that have been very closely connected to energy over the decades. And indeed, for supplying, it costs a lot to deliver a gallon of jet fuel to someplace like Afghanistan. So that's a concern as well. And then finally, of course, there's the concentration of CO2 in the atmosphere, CO2 and other greenhouse gases. Despite what seems to be the opinion in the U.S. Congress, there's pretty clear evidence that climate change is happening and that people are largely responsible for that. So those are the kinds of challenges we have to face. So how are we going to do that? Well, it would be a little bit sort of over the top to claim that a single university and a bunch of really smart students would do this by ourselves. But on the other hand, this is the kind of place where individual effort and groups really can make a difference. So this is a place where you can do game-changing research, and you will hear lots over this week of people talking about the kinds of things that are done here and the ways that we hope we will engage all of you. And we'll work on figuring out how to move those ideas into the world so that they can have an impact. And then finally, we hope to create a campus population that is as literate as possible about energy issues because, as I said, we largely have taken these for granted, and it's now time to pay a little more attention in a serious way. So if you look at what's here, we have a talented group of faculty. So I served for a period as a dean of one of the schools. So I know that the way this place really works is that, first of all, we get a bunch of really smart students to show up. Then we use the smart students to attract a really good faculty because it's way more fun to teach a bunch of really smart students than not. And then we use that good faculty to attract more good students, and so the whole thing kind of feeds on itself, you hope. So we do have a good energy faculty. There are, I don't know, 218 or 20 of them scattered across 22 departments in the university. So one of the reasons we created the Energy Institute was to try to provide a good way for those folks to work together when they wanted to without having to reorganize the whole university. That was known to be hard, so we chose instead to try to provide a good way to interact, and I think we've been able to do some things on that score. And you will hear, not from all, you'll be relieved to know that you're not going to hear from all 200 of these faculty members during this week, but you'll hear from a reasonable fraction of them. And I hope we'll give you some pointers to where to go look for the other parts. There really is a very rich and vibrant community of energy researchers here. And every time we sit down and try to draw some sort of box diagram of, first of all, you can never figure out who reports to whom in a university. That's those are like Jackson Pollock paintings, those kinds of reporting diagrams. But there are certainly clusters of interesting connections. So there's the whole policy and economic side. There's the energy impact side. There's dealing with hydrocarbons, the dominant part of our energy system now. There's all the renewables. So you'll hear lots about photovoltaics and wind and all kinds of other things like that. There's the business of understanding how materials work right down at the atomic and subatomic levels, because those are the ideas that we can use to devise new energy conversion devices. So the fundamental science that drives much of the other kind of thing. And then there's all the whole behavioral side. There's really good evidence that we could use energy more efficiently in buildings, for example, if all of us just paid attention. But we don't seem to do that. So why is that? Well, that's because all these pesky humans are involved in all of this, and so we have to figure out ways to deal with all of that. So there is a proliferation of interesting research centers and groups. These are often intersecting. Just a few examples. You heard about the Global Climate and Energy Project and SIMES. And SLAC, of course, is a big organization. SunCat deals with catalysis, Energy Modeling Forum, Energy Policy, Program on Energy and Sustainable Development, Energy Efficiency, and so on. So lots of groups. If you look at the Precourt Institute website, we have a description of the energy assets here at Stanford, and you can find the ones that you might be most interested in learning about. And of course, we've tried to leverage our connection with SLAC nearby. The SLAC is this 2-mile-long accelerator with associated synchrotron radiation facilities and a new free electron laser that gives unparalleled time resolution and spatial resolution for investigating materials properties. So it's a huge resource that we try to take as much advantage of as we can. And then we also have a close relationship with the National Renewable Energy Lab. So lots of opportunities to work with other folks who are in the energy arena. We have, at last count, something like 400 energy courses. The minute you put a number like that up there, it's obsolete. So I hesitate. Don't go count them. But there is a website on the Precourt Institute website. There's a little on the top bar that it says courses, and you can actually look in there, and it's searchable, and so you can kind of see the range of things. And there is a huge variety of energy-related courses here. So there's lots of stuff to do on the course side if you want to. We have a weekly energy seminar. Typically 150, 200 people show up. Students can do it as a course, but it's open to the community as well. And we have a very wide spectrum of speakers who deal with all kinds of aspects of energy going forward. So keep an eye out for that. There'll be the usual flyers all around. One of the things we tried to do with the Precourt Institute is to make Stanford's effort a little more visible. You can imagine that having people in 22 different departments, that can seem a little amorphous to the outside world. So we've tried to do a good job of providing a web portal and providing a faculty database and the course database that I mentioned and various newsletters. And you can take advantage of those if you'd like to know more about what we're doing. So it's just another example. And there's the course listing database, and so on and so forth. So we also have a good group of energy clubs, and you're about to hear from the Stanford Energy Club in just a moment. And it has various arms in the School of Business and the Law School. There's the Solar Car Project, and this afternoon we'll go visit the Solar Decathlon house that's in the competition for an award for the most efficient and livable house. So there's a Stanford Energy Journal. There's the Solar Car. Actually, I think that's an older version. And the new one is about to head off to Australia for a 2-week race across Australia entirely propelled by Australian solar photons. So we'll see how that goes. And this is some sketches of the house that you'll see. We do a whole variety of bigger symposia during the year. So watch for the Global Climate and Energy Project one, the Connecting the Dots, the Silicon Valley Energy Summit, and so on. There really is a rich opportunity to hear the most knowledgeable people in the world talking about important energy issues. And finally, we're actually working on the campus. If you've wandered around, you've seen lots of construction fences. Many of those are related to a new energy system for the campus. And it's actually a good story, but I don't want to spend too much time on it. The simple version is that all year round, we take heat out of some buildings through the cooling loop, and we put heat back in other places. So we're building a system now that takes the heat out of the buildings and pushes it back into the hot water side so that, that we don't buy that energy, we just reuse that energy. It turns out that all of us 100-watt heaters, that's about what you guys are, plus the solar collection of buildings, that adds up to quite a significant amount of heat over time. And this saves many tens of millions of dollars and reduces our greenhouse gas emissions quite substantially, and it reduces our water use. And on this campus, water use is a big issue. This is, in fact, a desert most of the time. So that's a big step. So I'll close here with a comment from President Hennessy, president of the university. And he basically pointed out that the energy challenge is such a big one. It's one that matters to so many aspects of human societies that it's the kind of problem that good universities, and we hope Stanford is one of those, it's the kind of problem that Stanford should be working on. And if we do our jobs right, then we can have global impact. And when I say we, of course, what I really mean is you. We hope at Stanford to educate generations of people who will lead the science and who will lead all the aspects of creating an energy world that is both sustainable in the long term, and also helps people live productive, comfortable lives. So that's the goal. The chances are pretty good that we won't have reached the goal by the end of the week, but by the time you're done here, I'm sure we'll be a good step along the way. I will say that I mentioned that I think a transition is underway now, and I'm actually quite convinced that that's true. But it's one that will be decades long. If you look at past transitions that were made from wood to coal and coal to oil and those kinds of things, they are multi-decade deals because you have to build a lot of equipment and build systems that do all these things. So we need to start now and stick with this over time. So that sustained attention to things that really do matter is something we're going to need to do. And that takes a lot of talented people to do it. So with that, I'll close. I'll be happy to answer questions if there are any. Thank you very much.